Welcome to Ask and Learn.
So the domain for this function is x is all real. Intercepts, we have one at 0, 1/4. There's no symmetry. And let's check for asymptotes. So we're going to set the limit to infinity and negative infinity. So the limit as x approaches infinity of our function 1 plus e to the power of x to negative 2, that's going to give us 0. So y equals 0 is an asymptote. And negative infinity is going to give us 1. So y equals 1 is another asymptote. Okay, and now we can look at increasing, decreasing intervals. So y prime is negative 2e to the power of x over e to the power of x plus 1, and that's all cubed. Set that equal to 0. This is inconclusive, so we can't use this test. All right, but y double prime, we can still look at concavity. 2e to the power of x, 2e to the power of x minus 1 over e to the power of x plus 1. That's all to the power of 4. Set that equal to 0, and we see a critical point at x equals negative ln of 2, which is approximately negative 0.693. So if we do the second derivative test, so this is f double prime at negative 0.693, it's going to be concave down here, concave up here. So this is an inflection point. All right. Now we can graph with the information we have. So we can graph our asymptotes first. Let's say this is 1. So we have one asymptote at y equals 1, and we have another one at y equals 0. We have an intercept at 0, 1/4. We have an inflection point at about negative 0.693, so that's about here. If this is 1, it's about, this is 1, so it would be somewhere around here. So this is where our inflection point would be, the x values of it. So it's going to be concave up here, and it's going to approach, as x approaches infinity, it's going to approach the 0. So it's going to go like this, concave up, and it's going to still be concave up until it hits the inflection point, and then it's going to switch to concave down and go to our other asymptote. And this is our graph.